The objective of our project was to design a scale model of a pressure flow system that both visually and functionally resembles the full-size system. This model will be used at trade shows to demonstrate the internal sealing mechanisms of the device to potential customers. Sealing devices are used in the oil and gas industry to separate toxic gas from liquid sulfur. The SX Seal 2000 is an advancement to the current industry technology due to its proprietary sealing mechanism. This allows it to be smaller, safer, and easier to maintain than competing technologies. This sealing system is able to operate under 3 distinct conditions. During normal flow, the system blocks unwanted vapor flow while still allowing the liquid sulfur to flow. When no flow is occurring, the system traps the unwanted vapor within the system. For an overpressure event, the system will relieve excess pressure to the downstream refining process.
The specifications and requirements for the project include the model's appearance to resemble the actual device while having the ability to perform all 3 operational conditions. The model must be user-friendly with visual control inputs and display. The model size and weight were also designed for convenience during transportation.
The model is constructed from 8 1/4 inch acrylic tubing. It is approximately 12 inches tall and around 10 pounds unloaded. The half pipe is 3D printed and is there for similarity to the full-scale model and to house the air and water inlets. As water fills the model, the float will rise and allow flow to continue through the orifice plate and downstream. This float and plug assembly in the center of the model is the most important component, as it accomplishes the needed flow separation between liquid and vapor.
The control box is constructed from steel sheet metal. It contains all the hardware necessary for device operation, including an air compressor and regulators, solenoid valves, and power supply. Most prominently featured is a 9-inch touchscreen display that will control device operation. On the right side, there is a power inlet, as well as air and sensor ports. As shown on the mock-up GUI image, pressure, flow rate, and the current operating state of the device will be displayed.
The Seahorse 1220 case is being used to transport the device and float assembly. The foam insert provides extra padding and protection for the components, and the water reservoir will be contained in a collapsible 16-liter bucket.
Centered around the model, the electronics can be administered by the sales representative or anyone who wants to see a demo of each operation. Below we can see how the electronics system will safely emphasize the SX Seal's characteristics.
In addition, an operator's manual was created to instruct the user on how to properly assemble, disassemble, operate, and maintain the model.